Now let's take a look at synthetic division, which is another way to divide a factor in the form x minus c, as we were looking at earlier. The first thing we want to do, and this is very important, is write each polynomial in descending order and be sure to include missing powers by using a 0. Notice we did the same thing with long division. Next, we'll actually follow this algorithm we have for using synthetic division. We'll see that in the next question. Write answers in the form q of x plus r of x over d of x, our quotient plus our remainder divided by our divisor. Notice that the highest power of the quotient will always be 1 less than the highest power of your original function. So if we begin with an x cubed, we'll end with an x squared. If we begin with our polynomial of a 5th degree, then our answer will be a 4th degree. And this is considered a shortcut, and we can only use it when things have the form, when divisors have the form 1x plus or minus c. All right. At least I can use it without adjusting anything. There is actually a way to make it work when it's not 1x plus c. All right, use synthetic division to find the quotient and remainder of this. Negative 4x to the 5th plus x to the 4th plus 6x cubed plus 2x squared plus 50 divided by quantity x minus 2. We begin by taking the value 2 over here, and you always want to think what number would make our divisor equal to 0. Well, that would be x equals 2, so we're going to use 2 right here. And we take each of these numbers as coefficients. Negative 4x to the 5th, 1x to the 4th, 6x cubed, 2x squared, 0x because we don't have a linear term, and our constant. Now the process is this. We take this value, bring it down. We're normally going to add there. Negative 4. We multiply 2 times negative 4 to get a negative 8 right here. Then we will add these two, so that's negative 7. Multiply negative 7 by 2 to get negative 14. We put that value here. Add these two to get negative 8. Multiply negative 8 times 2 to get negative 16. Add 2 plus negative 16 to get negative 14. Multiply this by negative 2. Add 0 and negative 28 to get negative 28. Multiply negative 28 by 2 again to get negative 56. Add these two to get negative 6. So our quotient is, and we read this off the bottom row, our quotient is negative 4x to the 4th. Notice we're starting at the 1 less than our degree. Negative 4x to the 4th minus 7x cubed minus 8x squared minus 14x minus 28. That's a constant. And our remainder is negative 6 divided by the original divisor, which was x minus 2. So minus 6 over x minus 2. Let's look at another example. Synthetically divide the following polynomials. Write the answer in the form q of x plus r of x divided by d of x. P of x is x squared plus 5x minus 7, and our divisor d of x is x minus 3. First thing I want to do is set this equal to 0 to determine that x is equal to positive 3. All right, so I'm going to put x equals positive 3 out here, and I'm going to put my coefficients here. So my x squared, my x, and then my constant. Those would be 1x squared plus 5x minus 7. Put those there. Now I'm going to bring down my first value. So I have a 1. Now I'm going to perform 3 times 1, which is 3. Add these two to be 8. Multiply 8 by 3 to be 24. Put that here. Add these two. That will be positive 17. So my answer is 1x plus 8, or x plus 8, plus 17, that's my remainder, divided by my original divisor, x minus 3. So x plus 8 plus fraction 17 divided by quantity x minus 3. Our next example, synthetically divide the following polynomials. p of x equals negative 12x squared plus 3x to the fourth plus 8x plus 4. And d of x equals x plus 2. The first thing we need to do is write this in descending order. P of x is not in descending order. So it would be 3x to the fourth minus 12x squared plus 8x plus 4. So we can use those values to fill in here. That would be 3x to the fourth. We have a 0, x cubed, minus 12x squared, 8 for our x, our linear term, and 4 for our constant. Now the value that makes our divisor equal to 0 is x equals negative 2. So I'm going to put that over here to the left. Now we will bring 3 down, our first value. Multiply 3 times negative 2, that's negative 6. Add these two, so that would be negative 6 again. We'll take that value, negative 6, times multiply it by negative 2 to be positive 12. Adding these two gives us 0. All right, put a 0 there. We'll take 0 multiplied by negative 2 to get 0. Add these two values to get 8. 8 times negative 2 would be negative 16. And then we'll add these two values to get minus 12. We began with an x to the fourth term, so the first term we'll have is an x cubed, so 3x cubed minus 6x squared plus 0x, I'm going to skip that, plus 8 is my constant, minus 12, that's my remainder, divided by my divisor, which was the x plus 2. 3x cubed minus 6x squared plus 8 minus 12 divided by quantity x plus 2. For our next example, we have quite a few missing terms. We're going to synthetically divide the following polynomials. We have c to the fourth power minus 256. We're dividing that by quantity c minus 4. Well, my divisor is 0 when c equals 4. So I know I have that part, c equals 4. Now, for my c to the fourth term, I have a 1, a coefficient of 1. There is no c cubed term, so we have a 0 for that. 0 for our c squared term, and 0 for our c term. But for our constant, we have minus 256. Now we'll bring down the 1 in the first place. 4 times 1 would be 4. Now we're going to add 0 plus 4 to get us a 4. Multiplying 4 that we just found by c value, which is 4, that's 16. 0 plus 16 is 16. 4 times 16 would be 64. Adding these two, 0 plus 64, 64, and then 4 times 64 would be 256, positive 256. Adding those two is a 0. So our remainder is 0. That means it's actually factors. So my answer is 1 c to the third power plus 4c squared plus 16c plus 64. For completeness, I'm going to write plus 0 divided by that quantity c minus 4. Because our remainder is 0, we don't have to write that term. However, I do want to include that just so we can be aware that I'm just not skipping something. All right, our last example for synthetic division is to synthetically divide f of x equals x cubed minus 4x squared plus 4x minus 16, given that 4 is a 0. Well, because 4 is a 0, that means we have x minus 4 as a factor. Or I could just dive into my synthetic division with x equals 4 to the left. Now let's write down those coefficients. We have 1x cubed minus 4x squared plus 4x minus 16 is our constant term. So I'll bring down my first value of 1, multiply the 4 I have as a 0 times 1. That's 4. Negative 4 plus 4 is 0. 4 times 0 is 0. 4 plus 0 is 4. 4 times 4 is 16, a positive 16. So adding negative 16 plus 16 is 0. My remainder is 0, which means, again, we knew it was a 0 because x minus 4 is a factor. So our result is x squared plus 4 plus 0 divided by x minus 4, or just x squared plus 4.